Good day everyone and welcome to this lesson. So we're still on the topic of exponents. Now today we're gonna do more examples of complex exponential expressions. So in these exponential expressions we are gonna be dealing with negative exponents and a base in a form of a fraction, also a base in a form of a decimal. Now when we're given this type of expressions, you first need to deal with whatever base you are given before you pay attention to the exponent. Now in the following example, I'm gonna show thoroughly how to do so. On each of the following expressions, we're going to be using the laws of exponents to help us answer these questions, and hopefully so we're going to simplify all of these exponential expressions. Let us consider the following expression. So we have the expression 10y to the power 4 over 4y to the power 6 inside the bracket and raised to the negative exponent of 2. So when you have a fraction raised to a negative exponent, the very first thing you want to do is turn that negative exponent into a positive one. So if you want to change a negative exponent into a positive one while you're given the base of a fraction, you need to use the reciprocate of that base. So how do you use the reciprocate of that base? You just swipe everything around. So now we'll have the numerator as 4y to the power 6 over 10y to the power 4. This allows us to change the sign of the exponent and it becomes positive. Now when you have changed the sign of the exponent, you can see that 4 and 10 have a common factor of 2. If it do not have a common factor, then we're going to go on to the next step. But since it has a common factor, you need to reduce it to the most simplest form that it can be. Now the common factor between 4 and 10 is 2. So we're going to divide these two numbers with their common factor. So 4 divided by 2 is 2. Now we still have y to the power 6 over 10 divided by 2 is 5, and we still have y to the exponent of 4. Now when you get to this part of the expression, now you're going to use the third law of exponent, the fourth law of exponent, which says raising a power to a power. Now you can see that y is the power of 6 and the denominator y is the power of 4. 2 as an invisible exponent of 1, also 5 has an invisible exponent of 1. So I'm going to multiply all those exponents with the exponent that is outside of the bracket. So now we'll have 2 to the power 2 y to the power 12 over 5 to the power 2 and y to the power 8. So this is what we now have. Now you remove the bracket since you have already multiplied the exponent which was outside of the bracket. Now you'll express these numbers in their whole number form. So 2 to the power 4, we know it is equals to 4, and we still have y to the power 12 over 5 to the power 2, we know it equals to 25, and we still have y to the power 8. Okay, so now we are allowed to divide the exponent of 12 with this exponent of 8. So now we'll have 4 to the exponent of y over 25. Now you raise that exponent of 12 minus by the exponent of 8. Now the y will only appear in the numerator and not in the denominator. Now this is equals to 4y to the exponent of 4 over 25. It once. Let us consider the following expression. Now you need to simplify this expression as much as possible. Now whenever you're given an expression in a form of the base being a decimal, the very first thing that you want to do is turn that decimal into a fraction. So you'll press the decimal into your calculator, and when you press equals to, you will get your fraction. It will always give you a fraction whenever it's a decimal. So 0,125, it's also the same as 1 over 8. Now you still go down with the brackets, and this was raised to the exponent of 3. Now when you're given this, remember when you want to change the sign of the exponent, you need to use the reciprocate of this fraction. So now we'll have 8 over 1 to the exponent of 3. Okay, now if you can remember, 8 over 1 is the same as 8 divided by 1. So 8 over 1 is the same as 8. 8 over 1 is the same as 8. So now we have 8 raised to the exponent of 3. Now when you have 8 to the exponent of 3, you want to reduce that 8 into its prime factors. Remember, I've showed you the trick. So you press whatever number you want to turn into the prime factor, which is 8, is equals to shift and then fact. So 8 can be represented as 2 to the power 3. So you write 2 to the power 3 raised to the exponent of 3. Now 2 to the power 3, you multiply these two exponents. So 3 multiplied by 3 is 9. So now we have 2 to the power 9. Now it's either you leave your answer like this, or you can press it into your calculator depending on what the question said. If the question said do not choose a calculator, you are not supposed to use the calculator. But if it did not say, you're supposed to write the final answer, and the final answer is here is 512. Let us consider our last and final example of the video. So we have the expression 1 over 4 inside the brackets raised to the exponent of negative 3x multiplied by 8 to the exponent of 2 minus 2x. Don't mind the 4, it was a mistake, it's of the next step. So whenever we have a sum like this and there's a bracket, we first want to deal with the bracket. As BODMAS tells us, brackets are the first thing you deal with in any expression or an equation. So now we want to turn this negative exponent of negative 3x into a positive 1. So we'll use the reciprocate once more. So now we have 4 over 1 to the exponent of positive 3x multiplied by 8 to the exponent of 2 minus 2x. So when you get to this point of the sum, you want to multiply every exponent inside the bracket with the exponent that's outside of the bracket. Now remember, 4 over 1 is the same as 4. So we're going to represent 4 over 1 as 4 to make things easier. So 4 to the exponent of 3x multiplied by 8 to the exponent of 2 minus 2x. Now this is what we have. Now we're going to use the third law of exponent, which says raising a power to the power. Remember, 4 has an invisible exponent of 1. So we're going to multiply that 1 with the 3x outside of the bracket. So now we finally have 4 to the exponent of 3x multiplied by. Now we want to reduce 8 to its prime factor so that we are able to deal with those exponents. Now remember, 8 can be represented as 2 to the power 3. Now this exponent will be placed inside a bracket. So it's 2 minus 2x, close bracket. Now we also want to represent 4 as a prime factor. 4 is not a prime factor, but we know that 4 can be represented as 2 to the power 2. Now the exponent of 3x will also be placed inside the brackets. So this is what we now have. Now what we'll basically do here is multiply every exponent with every exponent that is inside a bracket. So in the end game, we'll have 2 to the power 6x multiplied by 2 to the power 6 multiplied by 2 to the power negative 6x. So the first 2 to the power 6x is from this, and the second one is from 3 multiplied by 2, which is 2 to the power 6, and the third one here is 2 to the power 3 multiplied by negative 2x. So when exponents are expressed in the form of a binomial, we need to multiply them separately. So now the next step is, remember the laws, what the laws of exponents tell us. The first law, it says when we have the same basis, you are allowed to add the exponent. So now we can see that we have the base of 2, 2, and 2. So we can represent all of those numbers as one base. So we'll use the next part. So now we will only use 2 and add all of these exponents. So we have 6x plus 6 plus negative 6x. Put it inside a bracket. So now we'll have, this is all equals to 2 6x plus 6 negative multiplied by positive, it's negative 6x. This is equals to, you group the like terms, 6x minus by 6x is 0. Now we're left with 2 to the power 6. 2 to the power 6 is equals to 64. Here you have it. We have come to the end of our video. If it's your first time here, please like, share and subscribe.